Good morning. So this is the story of protein synthesis or translation. So all DNA starts or is stored in the nucleosis, all our billions of DNA, but we just want to copy a small little portion. So the RNA polymerase attaches itself to the DNA that it wants. So it takes out the DNA, puts it in here, and takes what the DNA that it wants. And it's only going to copy a small part. So in this case, I chose met-glycylase. So in DNA, the starting codon is always AUG, and the ending codon is UAA in this case. So then during translation, it'll turn into UAC, CCA, ACA, CUU, AUU. And there's so you can just see it. So the first step would be RNA polymerase picking the DNA that it wants, the small portion, and then it's going to break up into introns and extrons. So introns are the coded regions that are not being used, so this portion outside of the cell, and the exons are the coded region of the DNA to make our protein, so everything that we want is on the inside. So now translation starts, which turns the RNA into the amino acids or enzymes that we want, in this case the protein. So the next step is the ribosome, which is right here with the 5', 3' tail starting through the two sides of the mRNA. It moves through and that creates the protein. Then the ribosome sets the new RNA to the RER, which is the rough endoplasmic reticulum. So it attaches here at the bottom, sends in the DNA that we just created, and the whole RER is covered with ribosomes. So then in here, it buds off the protein that we have here and sends it throughout the cell. Then it goes all the way to the Golgi apparatus here. So it moves through all the cytoplasm in the cell to the Golgi apparatus. And the transvesicle ships the protein here. And then the final touch is the final trimming in the Golgi apparatus, which sends the protein to be able to leave the cell. And then the protein can leave the outside of the cell. And then this is kind of the diagram and the steps that I had, and that's about it. Thank you.